Now let's see a different kind of two-dimensional motion. Over here, we have a cannon which is going to fire a cannonball. So you can clearly see this cannonball is undergoing two-dimensional motion. There is motion happening in the vertical direction, and there is also motion happening in the horizontal direction. So again, what we can do is we can consider that the ball cannonball is actually undergoing vertical and horizontal motions separately, which are independent of one another as well. Now, uh, what is the difference between this motion and the horizontal projectile motion? Now, if you see closely, what's happening in the vertical direction is it's actually moving up and then it's moving down, correct? Which means for an object to move up, there has to be some non-zero initial velocity in the vertical direction. So that's the difference. In the horizontal projectile motion, there was the vertical velocity was zero at time t is equal to zero. However, in this kind of motion, the vertical velocity is non-zero at time t is equal to zero. So that's the basic difference between this motion and the horizontal projectile motion. Okay, now let's try and understand the horizontal motion with respect to graphs. Right, now what I'm going to do is I'm going to quickly share my iPad screen. Stop share. Yeah, here it is. So I think it should be easy for you guys to um, understand the kind of motion which the object is going to undergo in the horizontal motion, horizontal direction. So across the position time graph, the position time graph is actually going to be a straight line, because remember, in the horizontal direction the velocity is constant, right? In the velocity time graph, the velocity in the horizontal direction is constant in the horizontal direction, right? How about the acceleration time graph? Acceleration is zero. So time x and acceleration meter per second squared, it's zero. So it's going to be here. So this is easy, I know that. Okay, now let's go back to the simulation file. So if I go back, let's see what's happening in the vertical direction. So initial observations clearly tell us the ball is moving up and then down. Now, now as it moves up, you know for a fact the velocity is going to decrease in magnitude. And when it reaches the top, when it reaches its maximum height, the velocity actually becomes zero. And then it starts to descend down. And as it starts to come down, the velocity is going to increase in size, but in the opposite direction. To quickly recap it, to quickly recap it, while it is going up, the velocity is positive. If I consider x-axis, y-axis to be positive that way, but the magnitude of the velocity is decreasing in size. At one point in time, the magnitude becomes zero, which is when it reaches the maximum height. And after that, the velocity becomes negative and it begins to increase in size until it hits the ground. Now, what I'm going to ask you guys to do is in the next subtopic, I'm going to ask you to identify the position time, velocity time, and acceleration time graph for the vertical motion, considering that the y axis is positive upwards. Thank you.